Hello everyone, my name is Sabin Nakarmi and I'm going to present our research paper leveraging data-driven approach to empower assistive technology, which was written in a collaborative effort between London Metropolitan University and Felicia Interfaces. To start, let's talk about assistive technologies. The term assistive technology refers to a wide spectrum of tools, devices, and software that aid in communicative, sensory, physical, or cognitive functions for individuals with special requirements. It plays a very crucial role in promoting inclusive education, enhancing learning experiences, and empowering individuals with diverse abilities. The focus of this paper is on how data-driven approaches can add to the functionality of assistive technology to track progress of users. Now to talk about the aims and contributions. As I just said, the main aim for our research paper was to explore how a data-driven approach can be leveraged to empower the emerging potential of assistive technology and its impact on EdTech. Talking about what we contributed using this research, we identified key metrics that can be collected by assistive hardware for progress tracking, and we created and implemented an integrated system using COSMO assistive devices that was developed by Felicia in conjunction with a companion app on iOS, iPad, to process and visualize data that can be interpreted by therapists and teachers for progression tracking. We used Cosmo for our research and the experiment, so let's see what Cosmo actually is. Cosmo is a Bluetooth-enabled switch. It's also known as Cosmoid, and it's developed by Philips Interfaces. It works alongside an iOS application. It gives access to multiple training and learning activities that are categorized into various skills. So these skills are cognitive skills, mathematics skills, speech skills, music skills, etc. This can also be customized as a human interface device, basically a accessibility switch, which can register a keystroke to control 3D applications like YouTube or Spotify or any Bluetooth-enabled devices. The company actually works with various occupational therapists and schools where these devices are used in different therapy and educational settings for teaching different skills and conducting therapy sessions. This is what the Cosmo devices, assistive devices look like, and alongside is a schematic version of the device, which shows what's actually on it, the buttons, the charging ports, etc. So one way we added to the functionality of an assistive device is by adding progress tracking capabilities, uh, basically using the data insights, which is used for tracking user progress. Traditional therapy has progress tracking tools, but those are more along the lines of paper questionnaires or feedbacks. But the core concept for progress tracking using Cosmo came from discussions with actual therapists on how the hardware that collects data and the data that is generated can be integrated in a therapy session or a therapy environment. To that extent, the activity that was designed with predefined configurations that minimizes the external factors that could skew the measurements of the experiment. Repeated sessions with the same configurations are used to generate charts to visualize progress. There is a caveat where therapists will have to standardize the test that they give out to patients every single time because consistency is the key to getting accurate measurements for progress. To that extent, uh, for this experiment, after careful consideration and exploratory analysis, there were certain key metrics that were collected so that they can be used for progress tracking. The first one was number of trials. The number of trials is used to denote the number of times an experiment where the sequence of all devices was pressed. The total duration is the time the experiment was conducted, the total time. Response times is the time it took to press each specific device in each trial. This value is later used to calculate the averages for response times for each cosmos as well. And the force values is the force with which each cosmoid was pressed in each trial, because these devices come with pressure sensors as well. There are a lot of other metrics that are also tracked and collected for processing, but these four metrics are the key to actually track the progress of a specific user. Results in the form of graphs that can be visualized or interpreted by different therapists to track user progress. The figure shows the time it took for users to complete each individual trial in a particular session, and it's plotted against the average time of the specific user's overall sessions. So the highlighted plots are the times of each individual trials, and the dotted line is the average time. So the lower times denote better performance and vice versa. The variance in the times can be indicative of the patient's progress. The lower the time is, the better the performance. If the times are the higher, we can see that the user has not really progressed much. Now, taking a look at the time across sessions graph, this graph represents the average time for a user to have completed a trial over multiple sessions. If we take a look at the highlighted plots, these are sessions that have been conducted previously, whereas if we take a look at the plot that's been selected right now, this is the selected session which we are going to compare against the other sessions. Taking a look at this session, we can see that in this specific session, the response time is significantly lower than the other sessions, meaning in this particular session, the user made progress. The activity that was designed, which is called sequence, is named so because the activity consists of the user pressing 6 different buttons in a specific order. While pressing these buttons in a specific order, the response times for those presses is denoted in this graph. So the response time denotes the time taken to press a specific cosmoid after it was lit up. The specific cosmoids are represented with specific colors, which is represented in the graph as well. The figure shows two different types of plots, which can be seen paired up by color. The first plot, which has been highlighted right now, is the average of all similar sessions, because each session can have different configurations. These take into consideration the same configuration sessions, whereas the plot that has been highlighted right now shows the selected sessions average response times. Now, if we take a look at this plot, we see that the comparison between the average response times of a specific session versus the overall average of similar sessions. Here, if the average response time of the selected session is lower than the average response times of the overall session, it can be interpreted that as positive progress. In this case, which it is positive progress, because on average, the response times have been significantly higher, whereas in this specific selected session, the response time is lower. These devices can also be used by physical therapists or in a school environment with children who have physical disabilities to see if their specific physical strength has improved or they've made progress in that sense. To interpret the results of this value, first we also have to know that, like the previous graph, these have two different types of plots. The plots that are highlighted represent the force values, the average force values of overall all sessions conducted with similar configurations, whereas the plots that have been highlighted right now specific one single session. For positive progress to be interpreted, the value of the larger dot has to be higher than that of the smaller dots, meaning in this particular graph, in this particular session, the average force value, the force at which the buttons were pressed were significantly higher than the overall averages, meaning the user pressed the button harder than before, so indicative of progress in their physical strength. To conclude, I'd like to say that the experiment was conducted alongside Felicia with their assistive technologies to implement in an EdTech setting. The data was collected from therapy sessions and learning environments where the relevant metrics were built into the activities to facilitate progress tracking. And the experiment proved that the data is viable that was collected from the devices for critical internal decision making. And at the same time, it provides a means of progress tracking to therapists in the therapy or school environments. For future work, this um, can be used in conjunction with different machine learning models for adaptive gaming, where data will be processed to predict and adjust the difficulty for specific games or activities based on how the user is performing. Also, from a research perspective in special educational needs and disabilities, this approach can be utilized to discern if there are any specific markers and that can be physical or cognitive that can be recognized to potentially be used for predicting said conditions.